Alright, so it's day 6 of the Mexican adventure. So today we've gone out to the Sierra Negra outside Puebla to visit the large millimeter telescope. So we're about 4,600 meters up. I'm feeling a little bit nauseous. I felt better, got to be honest, with the altitude. It's pretty cold. Just started checking it down with hailstones. So I'm here with David. He's the what's your official role? Yeah?
LMT director and principal investigator of the LMT.
So could you sort of maybe just sum up what you use the LMT for, the main sort of science goals of this place?
Yeah, it's well. First of all, welcome. It's nice to have you here, James. So the LMT is the world's largest single-dish millimeter wavelength telescope, and that means it's an important infrastructure in the context of world astronomy. At millimeter wavelengths, we have the opportunity to study essentially the formation and evolution of structure throughout the entire history of the universe. And what's particularly important about millimeter wavelength observations is that we're able to probe the most obscured regions of star formation, planet formation, structure formation. And this is something that's not possible at optical wavelengths. So in the early stages of formation of stars, for example, this is taking place in the centers of dusty molecular clouds, and you just don't see that moment of formation, the early collapse of stars or the early formation of planets. And so with a millimeter telescope, you essentially have like this transparent view of these early epochs of formation, both locally in our galaxy, and also throughout the entire history of the galaxy. We're able to detect the early stages of formation of galaxies, just only a few 100 million years after the Big Bang. And with a big telescope, obviously we have more sensitivity, we have more angular resolution than the previous generation of single-dish telescopes, and so that makes the LMT a unique infrastructure.
And how would you sort of describe working here in this environment?
Beautiful. Not so much today. And you know, we have a little bit of this sort of granizo. It's not hail. It's a sort of, it's almost snow. But no, it's actually a very good site. I mean, we're here at the end of May, and we're moving into what's called the rainy season. And so typically the conditions, the observing conditions, aren't quite as good for the next few months because of the higher levels of humidity, the water vapor that builds up around the mountain, because we're only a few hundred kilometers from the Gulf of Mexico.
Does that mean, can you sort of take measurements at a time like this? When
So
it's,
right now, if we were working at in the lower frequency bands, yes, we could. We actually don't work during the day at the moment. And the other reason is that because it's daytime, the clouds have risen up through convection. So at nighttime, during the afternoons, at night, these clouds drop. We have clear nights, and we're working every night. But it is true to say that during the winter months, when it's dry, we have exceptional conditions, as good as you can find in Hawaii, as good as you can find many times even in the Atacama Desert. So it's an extremely good millimeter wavelength site.
Okay, cheers, David. Should we go inside before we freeze?
Yeah, let's go take a look.
All right, Ta, thank you.
Okay.